Hello Internet, welcome to another microprocessor tutorial. In the second installment of memory interfacing tutorial, we are going to interface a memory with a microprocessor. And in this tutorial we are going to take example of 8085 and 8086 microprocessors. Now 8085 microprocessor has 16 address lines and 8 data lines. Now I assume that you know the pinout diagram of 8085 and you know that address and data lines are multiplexed, but the fact of the matter is there are 16 address lines and a group of lines is represented by putting up this lightning symbol, and it has 8 data lines. Now before we actually attach a memory to 8085, we must understand that by virtue of having 16 address lines, it can be connected to a memory that has 2 raised to the power 16 locations. In other words, this microprocessor is capable of addressing to a memory that can have an address which is 16-bit long, ranging from 16 zeros to 16 times 1, as we discussed in the previous tutorial. So if you remember from the previous tutorials, this microprocessor is capable of addressing a memory whose address can be 16-bit long, or in other words, it is capable of addressing a memory which is 64K in size in terms of locations. So what we'll do is we'll take this address line and we'll connect this microprocessor to a memory which has 64K different addresses. And needless to mention here, the first address would be 16 times 0, which is more conveniently written as 4 times 0h, and the last address would be 16 times 1, which is more conveniently written as 4 times f. Of course, this is hexadecimal notation. So 8085 is capable of handling a maximum of 64K location memory because it has only 16 address lines. This is the underlying key point here. And the second point is it has 8 data lines. So this microprocessor can be optimally used with a memory whose register size is 8-bit or 1 byte in size. So if we have a memory that has 64K locations and each location is 1 byte, it will be most optimum to use it with 8085. So all these data lines, they will be connected to the registers within the memory. The data lines are going to be bidirectional in nature. So data will flow from memory into the microprocessor or from microprocessor into the memory, depending upon whether it's a ROM or a RAM. However, the address lines are going to be unidirectional because the microprocessor has to specify the address lines to the internal circuitry for going into a specific address. So there is no need where the memory is going to specify anything related to addresses to the microprocessor. So this is very easy to understand that address lines are unidirectional and data lines are bidirectional. This is the second key point here. Now if we extrapolate this concept to our second microprocessor, which is 8086. Now I assume that you already know that 8086 has 20 address lines and it has 16 data lines. Now just by looking at these numbers, you'll say that 8086 is capable of handling more memory. Now what does 20 address lines mean? 20 address lines mean that it can go to a memory which has an address which is 20 bit long. That is, it can go to any address which is effectively 20 bit long, ranging from all zeros, 20 times zeros, to 20 times 1, and 2 raised to power 20 is 1m or 1024k. So this memory that we attach here to 8086 will have 1m different locations or addresses, and understandably the first address will be 20 times 0, more conveniently written as 00000h to 5 times fh. So in other words, this memory that we can interface with 8086 is many a times bigger than what we could have interfaced with 8085. So this is a well-known fact that by adding just one address line we can double up the capacity of the memory, and similarly the 16 data lines will signify that this microprocessor is capable of sending 16 bits of data in one go to a register within the memory. So now you can see the difference between the two. So each of these registers can be 16-bit in size, and this microprocessor will be able to send those 16 bits of data directly into the registers of the memory. Once again, needless to mention here, the data lines are bidirectional in nature, address lines are unidirectional in nature, and there is a mechanism within the microprocessor that writes the 16-bit long address on the address lines, and once that address is written on the address lines, then microprocessor goes to that address in the external memory to access it. And we'll talk about that mechanism later, but this is how memory interfacing starts with microprocessor, taking examples from 8085 and 8086. Now please understand, each of these memories will also have address and data lines. Now the address lines of the memory are going to be directly connected with the address lines of the microprocessor, and data lines of the memory are going to be directly connected to the data lines of microprocessor. So essentially microprocessor has very few things in its pinout diagram. It'll have address lines, it'll have data lines, it'll have read or write lines depending upon whether it's a RAM or a ROM. Then it'll have enable chip and a few others that we will see. But the majority of the lines will constitute data and address lines because read, write, enable and other such control pins are going to be similar in all the memories. And the difference between smaller memories and bigger memories is only between the number of locations that they have and the number of data lines that they have. That makes the size of the chip bigger or smaller for any memory. And thank you so much for watching this video. You have a good day and a good life. Bye.